All right. Well, hi everyone. Welcome. Thanks for attending the workshop here today. My name's David Wilcox. I'm the program leader for Fedora at LYRASIS. I'm joined by my colleague Arran Griffith, who's the program coordinator. Aaron's going to be helping out, sort of fielding questions and kind of managing the Q&A and that sort of thing. And so, just before we get started here, feel free throughout the workshop to drop in questions. The Q&A function is probably the easiest way to do that. And there's also a comment feature. So whatever you're comfortable with, I think Aaron's going to try to monitor both of those, but I can stop kind of throughout the presentation to answer questions. We've kind of built in time for Q&A throughout the talk. And I'll just drop in, share a few things here off the top. So my slides are available. Let me just put them in the chat. Go. So if you use that link, you're welcome to follow along with the slides during the presentation, and that'll be helpful partway through here. I'll shift to some hands-on work, and I do have some Fedora instances that you'll be able to claim and use for the workshop if you'd like. So the hands-on stuff is optional. You can just watch the demo if you prefer, and sometimes managing multiple screens on a desktop can be challenging, but if you'd like to follow along and if you'd like to participate in hands-on, we'll show you how to do that as we get into to the workshop here. But this is intended to be fairly introductory. We've updated this workshop with some features from the latest version of the software, so we'll be covering those. But we're not assuming that attendees have advanced knowledge of Fedora or anything like that. We're going to cover the basics as well. So just in terms of learning outcomes, the point here is to kind of understand what the software can do for you, as well as sort of the key capabilities of the software. We're not going to be going sort of in depth into the command line or anything like that, but we'll cover sort of the main features that are made available through the API and just provide an opportunity to get some hands-on experience with the software. So again, we're starting here at a high level introductory, not assuming folks know anything about Fedora. So if you're new to the software, Fedora is open source repository software. It's used to store and preserve and provide access to digital objects. And one of the things that kind of stands out about Fedora is its flexibility. It really allows you to model your content in whatever way is best for your local needs. And it achieves that primarily by leveraging linked data, so semantic relationships using Rdf. This is just a brief introductory workshop, so we're not going to do sort of a real deep dive into linked data, but Fedora does leverage some of those capabilities, which is how it provides as much flexibility as it does when it comes to modeling and describing your objects. It's also scalable, so it's designed to support millions of objects, both large and small. And it's also designed to interoperate with other applications and services. And I think this is something that is not necessarily unique about Fedora, but it's been a design principle from early on, where Fedora doesn't have much of a user interface. We will explore sort of the administrative interface during this workshop, but it's designed to allow institutions to build their own front ends or use one of the existing community front ends, which we'll talk about here shortly. So just in terms of the value proposition, why do institutions tend to adopt Fedora and use it? Again, I think the flexibility is one of the main selling points here, the capability to handle both simple and complex use cases. And that's really, when you're starting out with a repository, your use cases might be relatively simple, but they can grow in complexity over time. And so Fedora is sort of designed to grow with the complexity of your use cases and be able to handle that complexity as it increases.
David, I'm just going to stop you for a sec. There's a question. Somebody's asking to talk a little bit about the interfaces that are being built on top of Fedora 6.
Sure. So I'm going to show some examples of existing websites. Fedora 6 is not quite in production yet, so you won't find production examples, but very briefly, there are two popular frameworks, which again, I'll talk about in a moment here. That's Islandora and Samvera, that both use Fedora kind of as the backend. but there are a number of institutions that also have built a custom interface on top of Fedora. So I'll talk about that again in a little bit more depth and show some examples, but those are the kind of the majority of users. There are some other smaller kind of community run front ends as well. Fedora is another example in the European context of a Fedora front end. So there's these community projects that you can adopt, or you can build your own. And I think there are folks that there are examples of those, and I will show a couple of those momentarily here. But in addition to the flexibility, content in Fedora is also durable, and we'll talk a bit about the features of Fedora 6 in particular, but the support for long-term digital preservation has been a key component of Fedora and a big reason why a lot of institutions adopt it. But it's also fair to say that it's been successful. It's deployed at hundreds of institutions around the world, and this tends to be important for institutions that are thinking about software that they want to adopt and deploy, making sure that it's broadly used and that there's kind of a community around the software. As well, and this is increasingly true in version 5 and version 6, Fedora is really standards-based, and we'll talk about the features, and I'll give sort of a highlight of the various standards that Fedora implements. But this is really useful, especially if you, in the future, want to get your content out of the repository and maybe put it in a different system. Because Fedora is so standards-based, getting that content out is possible, and then you can, there are tools to kind of extract the content from Fedora, and then you could put it into a different system. So there's no sort of vendor lock-in that you might have in some other systems. And finally, Fedora is backed by a thriving community, and this is another one of the main reasons why institutions adopt software like Fedora. There is a strong community around it. There's mailing lists, there's Slack, and there are user group meetings and lots of different ways to connect and communicate and to get support. You know, folks that ask questions about the software tend to get answers fairly quickly, and there's a dedicated team that's there to help out. Just in terms of Fedora 6, so this is the latest version of the software. I'll talk about where we are in the release timeline a little bit later in this presentation. But this is the newest version of the software. And what we've done is remove and sort of rewrite the kind of back end of the software to enhance digital preservation capabilities. So we've adopted the Oxford Common File layout as a standard for how content is laid out in the repository, so that it is transparent, both human and machine readable, done in accordance with standards. As well, we've really focused a lot of effort on migration tooling. It's been challenging for some users to move forward, particularly from version 3 to version 4, or version 5. So we now have migration tooling that will allow users to migrate forward from all previous versions of the software. We've also added a simple search function that's built in. I'll show that later. That allows you to search the repository kind of in a quick and easy way. You know, Fedora does still support more robust options like Solr or Elasticsearch, but it does have kind of a built-in administrative search component now. We've done a lot of work in the performance and scale, so it does perform much better than it had in the past, and we can validate that because we've added sort of capability to collect and report out metrics from the repository in kind of a dashboard. So there's lots of new kind of capabilities here that we've introduced in the software. So getting back to the previous question about front ends, as I said before, Fedora, you know, fundamentally is a middleware application. It is designed to interoperate with other things. So you can build a custom framework. I'll show at least one example of a custom site that's built on Fedora. But Samvera and Islandora are both commonly used options in the community, and they provide a lot of functionality that you might otherwise have to build and design in a custom way. So it could save you a lot of effort if you're starting from scratch or if you're migrating from a different system. For those with specific needs or maybe very lightweight needs, it might make sense to kind of build an interface on top of Fedora in a custom way. Lots of people do that, but these community projects are also really useful. So I'll show a couple of examples just to give you a sense of what Fedora looks like when it's deployed, serving various use cases. So institutional repository use cases are fairly common. This is just a these are all public websites. I've included the URLs in case you want to go kind of take a look. So this is a Samvera-based repository, George Washington University, and just supports kind of typical self-deposit, mediated self-deposit, institutional repository type use cases. So built with a sort of Ruby on Rails Samvera framework at the front end, but using Fedora in the back end for the storage and the persistence of the content. Similarly, this is another Samvera site, but with a bit of a different look and feel, focused more on research data, integrating things like Globus, and that's at the University of Michigan. This is a custom interface, so they can look lots of different ways, but this happens to be a custom interface that they've built at the University of Maryland. And this is focused on newspapers, so special collections are a fairly common use case, paged content, scanned books and newspapers, those sorts of things. And this is a fairly large historical newspaper repository, again, with a sort of custom front end on top of Fedora. And then this one is an Islandora example, built fairly recently in New Zealand. It's a pretty interesting site, lots of special collections. It has a translated interface, so sort of multilingual. And again, these all have a sort of different look and feel. They all support different use cases and have different front ends for accomplishing that. And the common denominator here really is just on the back end, Fedora is being used to store and persist those the files and the metadata for these various collections. So I'll talk a little bit about some of the fundamental concepts, how content is stored and organized in Fedora. Fundamentally, everything in the repository is a resource. And these resources are also web resources because they have URIs, so they have unique identifiers that can be accessible on the web. Now, of course, you can apply security. You don't have to expose everything in your repository just to the open internet, but everything you create in Fedora does have one of these URIs, and so it is potentially web accessible. And within this concept of a resource, you basically just have two types of things. You have containers, which are largely kind of metadata resources, and then you have binaries, which are your files. So that's your PDFs, your JPEGs, your video files, your what have you, whatever content you're putting in your repository. So really everything in Fedora is just kind of one of these two things. It's either a container resource with some metadata that's describing the thing, or it's a binary file that you've uploaded to the repository. And all of these things can be described in various ways with properties, and those properties are made up of Rdf triples. Now, again, we're not going to go in depth into linked data here. These are sort of fundamental building blocks of linked data for used for description. But that's basically how Fedora kind of organizes and describes content. You can, of course, have XML-based metadata or any other sort of file-based metadata. Those just get uploaded as binary files. So you don't have to use RDF to describe everything if you don't want to. There are just some default Rdf relationships, and then you can build on those if your use cases support or have a need of linked data. And you can build up sort of containment hierarchies where you have containers that contain other containers and binaries, so you can sort of build things up. And I'll show kind of an example of that. So if you take a resource like a book, you can build a book in lots of different ways. You can just have a single PDF that captures the entire book, or you could do something more complex like this, where you have kind of separate page containers and that sort of thing. So I'll walk through this very briefly. If you built a book collection in Fedora, the collection itself would be a container because everything in Fedora is either a container or a binary. And you might have some description for that collection, or it might just be a title. And then within that collection, you might have, one or more books. Each of these books can be represented as a container, and then those books have pages, and you can have containers that represent those pages. And at each level here, you could have properties that are describing these things. And then at a certain level, you're sort of uploading the files. So, your page scans, it might be a high resolution TIFF. There might be a lower resolution JPEG that functions as a thumbnail. But this is a fairly typical sort of hierarchical structure. But Fedora also allows you to have sort of more complex relationships if you need them. So you could take the same book and store it in more of a flat kind of non-hierarchical way, but then build up those hierarchies using Rdf relationships. And this would allow you to do things like, for example, have a page that belongs to more than one book, or a book that belongs to more than one collection, without sort of copying and pasting things all over your repository. So you might have a use case where you have, an anthology that's collecting various pages from various books, and you could use these relationships to kind of describe that and build it up. And you could present it to the user as a hierarchy, but in the back end, really, it's all just Rdf relationships that are connecting various resources to each other in various ways. So, certainly this hierarchical, let's move back here. This hierarchical relationship is the most common. I think most repositories, tend to have fairly hierarchical structures, but Fedora does allow you to also have more sort of dynamic and complex structures if you have those kinds of use cases. And when you look at these resources in the repository, as we'll do shortly, everything just has these properties with relationships that sort of connect up different things in the repository. But we'll look at that very shortly here when we get on to the hands-on portion of the workshop. Just a brief note about standards, which I've talked about before. There's a link to the Fedora API specification. So some of the work that we did previous to this version has been to standardize the API. So it's documented. And this really helped us because when we went from version 5 to version 6, we maintained the API more or less as is. We added a bit of functionality in terms of search API, but the actual core functionality really hasn't changed between version 5 and version 6. And this really allowed us to make the software easier to upgrade. So when Islandora upgraded from version 5 to version 6, it didn't actually take them all that much work because they were using the API from version 5, and we just didn't change it significantly between 5 and 6. So that standardization really helped us, and it's something that we will continue to do in the future. Maintaining these standards and adhering to them. Okay, so just a little bit on core features, and then we're going to go into some hands-on content here. So this slide has a lot of information on it. I'm going to break this down, but then we're actually going to cover each of these numbers in separate slides. So at a high level, all this is trying to show is on the left, and sort of the bold text, these are you can think of these as the core features or services that Fedora provides. And on the right-hand side, these are just in the sort of grayed out text, these are just the standards that we're using for each one of these. And I'm not going to go into a great deal of detail on the standards themselves. You can look them up if you're interested in learning more about them. There's lots of detail there. They have their own communities around them. The point is just to show that for most of these services, we're doing them in accordance with a standard rather than doing them in a sort of customized way. So I'll go through these very briefly here. Off the top, there's the sort of basic resource management stuff that you would expect, creating, reading, updating, and deleting, what's sometimes called CRUD. This is just kind of the most basic functionality that you would expect your repository to provide. And here we've adopted the linked data platform, which is where we get these concepts of web resources and containers and binaries and those sorts of things. Fedora also provides versioning, which I'll talk about here a little bit later in the presentation. And there we've adopted a standard called Memento, which is used by things like the Internet Archive for providing versions in a standardized way. Authorization, so security, being able to control what users and groups can access what content in your repository. Here we've adopted web access control or WebAC as a standard. Fixity, which is digital preservation, doing checksums and that sort of thing. Here we've got some HTTP standards that we're using. The simple search doesn't have a standard associated with it. It's really more kind of custom. And then messaging I'm going to talk about much later, but that's another feature here that has an activity stream standard associated with it.
David, I have a question here from
Yeah.
the Q&A. What kind of properties can be searched through the simple search? The RDF properties or also the content, if that's possible?
So we'll cover the simple search a little bit later in the presentation, and there's some documentation there. I don't recall off the top of my head everything that it allows you to search, but when we get there in the presentation, I'll show you what's available. But you definitely can search across various properties that are in the repository. But yeah, when we get to the simple search, I'll get back to that question and provide a sort of show in the interface where that's covered. So again, just to go through these in a little bit more detail, CRUD, this create, read, update, delete, we're using this for creating and managing resources, but also these kind of form basic tools for content modeling. And there are lots of ways to do this. We're going to use the HTML interface here today because it's a little bit simplified and easier to use. In a lot of cases, either individual people like developers or frameworks like Islandora or Samvera would be using the more of a command line type interaction model with that, and it's much more robust. So you can use curl is very common, but also lots of programming languages have their own sort of client libraries that would allow you to do these kinds of interactions. So let's take a look at this. I'm going to switch now to doing some kind of hands-on stuff to sort of show how this works. And there's a link in the slides, but I'll also share this with all of you. So we spun up some Fedora instances, basically sandboxes for everyone to use. I'll give you a link here. So if you'd like to participate in the hands-on, just navigate over to this the spreadsheet. You'll see that there's a column for URLs and a column for initials. Basically, just pick any of these URLs. They're all the same, and put your initials or anything really in the initials column just to claim it so that no one else takes your instance. These have been live on the internet for probably 12 hours or so. It is possible that if you go into your instance, you'll find that someone else has been kind of playing around in there. It should be okay, but if your instance is really messed up, you can always just grab another one from the list here. I think based on the number of participants, we have more than enough. So again, if you'd rather just kind of watch along with the demos, you can do that. There shouldn't be a username or password on these, but if it does prompt you, this Fedora admin with the A and admin capitalized should function as the username and password. But when I checked my instance, it didn't ask me for one. So I think it probably won't ask you for one either. If you go there, you should see this kind of landing page with a blue button that you can click to go into the sort of top level of the repository. I just have a little test container in here that I was playing around with to make sure everything worked, but yours is probably empty unless someone else's has been in there. So feel free to drop questions into the chat if you need some help there. But otherwise, we'll continue here, and I'll be sort of flipping back and forth between the slides and the repository to kind of do stuff. This slide here is really more for developers and folks that are a bit more technical. We're going to be using the HTML interface, which, as I said, is kind of an administrative view into the repository. It's not really meant for a public endpoint. It's more meant for sort of administering your repository from the back end. But it is actually a direct connection to the API. So as we're doing things in this HTML interface, we are using the API, and this is just a bit of a cheat sheet to show you, based on the different parts of the interface, what kind of verbs we're engaging here to do different API operations, whether it's a get or a post or a patch. Again, this is more for the technical folks, people that are kind of familiar with working with APIs in the command line. If that's not you, then you can more or less ignore this slide. It's really just there for reference. And similarly, I'll just kind of explain the way these slides are laid out as far as the exercises go. On the sort of top 2/3 of the slide, these are the things that I'll be doing and that I'd encourage you to do. This is sort of using the interface to work with the repository. The text down below in the sort of reddish box, this is the equivalent curl command that you could use on the command line to accomplish the same thing. So for developers, feel free to try out the curl stuff if you'd prefer. But for most everyone, I'd suggest just kind of following along in the HTML interface. It's going to be a little bit easier. So let me just briefly kind of show what's going on here. This is at the top level of the repository. You've got the URI of the resource at the top, the identifier, and then a brief list of properties. We haven't added metadata or anything here, so you really just have some RDF types that say that this is a container and that it's a resource, and when it was created, when it was modified, those sorts of things. On this side of the screen, you have the ability to create new resources, give them identifiers, and update properties. And there'll be some other controls that appear as we start to create new things in the repository. But let's start walking through some of this stuff. Again, this is really basic, just to kind of show you the kind of basic functionality of managing resources. So I'm going to create a new basic container, and I'm just going to call it image-collection. So I'm going to go over here at the top. If you drop down this list of types, you'll see there's a bunch of stuff here. We're going to focus on the most common types, which are basic containers and binaries. These like direct containers, indirect containers, that kind of stuff. Those are more complex things that you can create. A lot of people aren't making much use of those, but they are in the linked data platform specification, which we've implemented, so they are available here. But we're not going to be covering those in this workshop. We're just going to stick with the basic stuff. So we'll create a basic container. If you don't give Fedora an identifier, it will create one for you. It'll just be a bunch of kind of ones and zeros and letters. It'll just be sort of a random identifier. We're going to give simple identifiers to resources in this workshop just to make it easier to kind of see things and navigate. But if you're running a repository in production, you may want to stick with auto-generated identifiers that don't have sort of semantic meaning embedded in them. But here I'm going to call this, I think it was image collection. Yeah, so I'm going to call this image-collection. The RDF box here, if you wanted to, you could pre-populate a resource with a bunch of properties when you first create it. We're not going to do that here. We're just going to create kind of an empty container. So I'm going to hit the add button. So as soon as you hit that button, it will take you to the new container that you created, and you can see at the top the URI reflects that. It's added this new image collection container to my repository, and it has a small set of properties here based on when it was created and modified, and sort of what it is. And so here I'm going to create another basic container as a child of the image collection container, and I'm going to call this one Andromeda Galaxy. So clicking over here, I've got my basic container, I'm on the image collection, and as an identifier, I'm going to call this one Andromeda-Galaxy, and hit the add button. So all we're doing here is building up a really basic repository hierarchy. You can see you've got sort of your home container, and then the image collection, and then Andromeda Galaxy, and they all have these relationships with each other. So they're structured as a kind of small hierarchy within the repository. And then of course you could use RDF to make whatever connections you want to other resources that might be in your repository. Some of these slides are really just here for reference. So this one here is just kind of explaining that every time you create a resource, you get redirected to it, and that's kind of the equivalent of doing a GET request via the API. So it's giving you back and retrieving that resource. So those are basic containers. I'm now going to upload a binary file. Here you can download one if you like. This is just a JPEG from NASA that you can pull down, or if you just have something locally, you can upload that. But here I'm going to create a binary resource within the Andromeda Galaxy container, and I'm just going to call it Andromeda.jpg just to sort of distinguish it. So here I'm in the Andromeda Galaxy container. I'm going to use the drop-down menu to select binary. As soon as I do, I get a little file browser because it's a different, because now it's asking me to upload a file. I will just call this one Andromeda.jpg, and then I'll go browse for that file. So I think I have it here from a previous workshop. Here's Andromeda.jpg. So there we go. I'll hit the add button. And when you do that, you get a slightly different screen. So this is a binary file. It's not a container. And so you get different sort of properties here. It pulls out the file name and the MIME type. You also get the checksum, which we'll talk about a little bit later. You get a button so you could download the content, and you could also check the fixity. And again, we'll talk about that a little bit later in the workshop.
Question here, David. When one needs some kind of validation of metadata or data, is this done on the client or the server?
So if you're talking about checksumming, for example, with a file, then that's done. So, and we'll talk about this a little bit later, but when you upload a file to Fedora, the server will calculate the checksum. So this sort of checksum here was calculated by the server, by Fedora, when the file was uploaded. And then if you were to hit this fixity button, the server would then recalculate the checksum and compare it to the value that's currently stored and let you know if there's a mismatch there. We're not currently doing validation with the metadata. Validating RDF can be a little bit challenging because there's no guarantee of the order of the triples, but we have been talking about that. Can we sort of choose a serialization format that's sort of the standard and then validate against that? But file level validation definitely happens, and that's happening. The server is doing that whenever you upload a file into the repository.
One additional question: if someone wanted to upload in bulk, would they need to use the CLI, or can they do that through this interface as well?
Yeah, you would have to do something probably scripted on the command line or use a tool through this interface. REST APIs are sort of single operation, and so using this kind of HTML interface, you'd be uploading one file at a time. If you're using something like Islandora, for example, Islandora does have batch ingest functionality. There's a really great tool that we've been using to demonstrate some of the migration work called Islandora Workbench, where you can basically just generate a CSV file with all of your metadata and files, and upload all of that through the command line into an Islandora instance and do batch ingest that way. Samvera, I believe, also has some batch ingest tools, but you could also script something fairly simple on the command line if you wanted to do that. But yeah, the short answer is this interface is sort of a single file only, but there's lots of ways to sort of outside of this context script batch ingest, but it would be on the command line side in most cases. And this again is just kind of explaining what's happening when you're getting that binary file back. Okay, so that's creating containers, that's creating binaries. Now we'll very briefly show sort of updating properties. There are different ways to do this. So you can upload an RDF file and have Fedora pull those properties in, on the command line. Through the HTML interface, you can use Sparkle Update, which is a query language for creating and managing RDF to add properties or manage properties. But again, this is probably not the most efficient way to do this. This is for demo purposes. This is kind of showing how this works, but there are ways on the command line to do more. And of course, again, if you're using primarily XML-based metadata, you can just upload those XML files as binary files. You don't have to convert your metadata to RDF, but if you do want to do that, or if you're already using RDF metadata, then Fedora certainly supports that. But here, I'm just going to add a simple title to the, not the file I just uploaded, but to the Andromeda Galaxy container that contains it. and I'm just going to give it a Dublin core title of Andromeda Galaxy. This is, very simple operation here, but basically just if you're not familiar with Sparkle Update, all this is saying, the sort of open and close brackets here indicate, this particular resource that I'm currently operating on. Then DC title is, Dublin core title, and then in the quotation marks is the title Andromeda Galaxy that I want to give to this resource. You could do a whole workshop just on Sparkle Update, so we're not doing a lot of depth on that here. But if I go back up, I'm going to use the little breadcrumb trail to click on Andromeda Galaxy to go back here. You see here it says children is 0. Quite likely that's because my browser is caching this. If I refresh this page or do a hard refresh here, there we go. So a lot of web browsers will fairly aggressively cache, and you might have to force a refresh of the page. In my case, I just held down the shift key and hit the reload button just to show that there is a child resource here, which is the Andromeda.jpg that we uploaded previously. But here on the Andromeda Galaxy collection, or on the container, I'm just going to go down to update properties. This is all sort of RDF ontologies, and this is just kind of a template. These are all preloaded in case you want to use any of these, and Dublin core is sort of at the bottom here. If this information wasn't here, I'd have to provide it, or in order for this to work. And this is all, again, just sort of a template down here. So where it says insert, and you can actually just copy paste this from the slides if you prefer. Or you can kind of type it out. But of course, typing it out means I'm more likely to make a mistake, so hopefully I don't. But here I'm just saying, insert a DC title of Andromeda Galaxy. I'll hit the update button. So the interface here just updates the URI to use the title. But if you look at the address bar, it is still the same URI. Nothing's changed there. And in the properties now, there is a DC title of Andromeda Galaxy. So that's been added in, and you can modify, update, delete, do whatever with these properties, other than the system properties, which Fedora won't allow you to delete the Fedora properties because those are required by the system to work. So that's create, read, and update, and then we're just going to do delete just to finish off the sort of basic CRUD, examples here. And I'm going to delete the JPEG that I uploaded. So again, here, if you don't see this, you might just need to do kind of a hard refresh on this page to see the child resource. But I'm going to click back to it here. So I'm on Andromeda.jpg. And if I scroll all the way to the bottom, I see the delete button. Again, this is interacting directly with the API. So as soon as I hit that delete button, it's going to delete the resource. Most interfaces like Islandora or Samvera would have more controls here and would, maybe ask you if you're sure you want to delete it, or put it in, a kind of deleted state without removing the file entirely. But here we're operating directly against the API, so it's a little bit more dangerous. So just be careful if you're kind of playing around in a live repository, because as soon as I hit this button, that resource is gone. And now if I hit the back button in my browser, again, it looks like it's there because it's cached. But if I do refresh, what I get here is what we call a tombstone, and hopefully you can read that. This is just an indicator that there used to be something here and it's gone now. And this is kind of best practice for using URIs in a production online environment. It's generally bad practice to reuse a URI once you've already published it. Because if someone had cited that resource and then the resource changes, then you've kind of broken their citation. So in this case, if you did delete it and someone went to retrieve it, they would at least get a message saying that it used to be there and it was deleted, and here's when it was removed. And if you did this on the command line, you would get an appropriate HTTP response code as well, indicating the same. You can delete a tombstone. I'm not going to show that here, but there's a command line command that you can run, and it's documented in our API documentation. So, if you were in a development environment, you might be sort of creating and deleting resources all the time, and you want to reuse URIs in that case, and Fedora will allow you to do that. But by default, it will prevent you from reusing a URI. And again, some of these slides are just for reference if you want to go back later just to sort of see what's going on there. Okay, so, and yeah, feel free to drop questions in. I'm happy to go back and cover any of this stuff in more detail. But I'll move on here to talk a little bit about versioning, which is another kind of important feature that Fedora provides. So versions, and I'll talk a little bit momentarily about what versions are, but these get created either automatically or on demand. In the current setup that you're using, versioning is automatic, so it's been enabled for every action, so versions are being created every time you make a change. You can disable versioning and then kind of just version things individually whenever you kind of deem it necessary. And in terms of retrieval, we are using the Memento Protocol. I'll say a little bit more about that, but this allows you to sort of request a version out of the repository by giving it kind of a standard date time that you're looking for, and the repository will respond with a version as close as possible to that particular date time. So, this is kind of interesting. The Internet Archive uses it, the British Library, a few other sites that are using this protocol. So very briefly, what is a version? It is itself a resource. So a version has a URI, you can link to it, you can find it independently. And it contains the contents of a resource at a point in time. So it's essentially a snapshot. And importantly, it's immutable. So this just means that you can't change a version once you've created it. And we'll see examples of that. You can delete it, you can restore back to that version, but you can't edit a version. It's intended to be a kind of snapshot of a resource at a given point in time. It has a date down to the second. So this is the Memento Protocol. It's discoverable, so you can ask a resource if it has any versions, and it will respond back with a list. And you can create it using a version API. So it's not, you don't create versions just using the basic CRUD operations that we were just looking at. You create it using the versioning API. But as I said, that's happening automatically in the way the repository is currently set up. So we'll have a chance to look at that. And in terms of the use cases here, there are lots of reasons why you might want to create versions. So if you're doing kind of metadata editing over time and you're adding properties or you're modifying things, you might want to have a history there just in case someone makes a mistake and you want to roll back, or you want to know, who made a change when, then, versions will allow you to sort of track all of that and maintain a complete object history. They're also useful from a digital preservation perspective. It's generally considered best practice, when you want to, declare that a resource is sort of preservation ready, that you can cut a version of that resource, and then it's sort of a snapshot of a point in time. And then if you make further changes, you might want to cut, other versions, but maintaining these sort of immutable snapshots is kind of good practice from a digital preservation perspective. And I'm not going to go into a ton of detail here, but there is a link if you want to read about the Memento specification. I'll talk about it a little bit. It has a few sort of concepts that Fedora does implement. So based on this spec, a version is referred to as a memento. So when you create a new version, that version is referred to as a memento. We have this concept of time gates. So this is kind of the endpoint where you would say, give me a version of this resource at a point in time. And the time gate responds back with the time map, which is the list of mementos. And of course, there's the original resource, which is the thing that was versioned. So this is just kind of the language that Memento uses. And since we're implementing that specification, then we try to make sure we're mapping onto those concepts.
Question here, David, related to versions. It says, are versions created over the metadata of the object in Fedora RDF properties, or in case of binaries also affects the content that is stored?
Yeah, so if I understand correctly, you can version both. So you can version the metadata, so that's the RDF, the properties, those do get versioned, and you can also version binary files. Binaries are stored based on their checksum, so you're not going to get a new version unless the checksum changes, which means the file has changed. But yes, you can. When you create a version, you're just getting a snapshot of that resource, but you can do it on the containers, or you can do it on the binaries, or both. In this case, it's fully enabled in the repository, so every change is creating a new version. But so far we haven't, uploaded different versions of a binary file, so that hasn't been versioned in the workshop here. So let's play around with versions a little bit. I'm going to create a new resource in Fedora in the image collection container. I'm just going to create another basic container, and I'm just going to call it map. So I'm going to go back here. I'll just use the back button in my browser, and then the interface here is responsive. So I'm zoomed way in, so that's why it's kind of collapsed some of the controls. If I reset my zoom, it'll go back. So I'll use the breadcrumb trail and hit the image collection container. And then I'm going to create a basic container at this level. And I'm just going to give an identifier of map and hit the add button. So I've got this map resource. And then here, just to show you, you have versions are being created automatically. So if I scroll down, you can see there's a little versioning section. It tells you it's enabled automatically. And if you want, you can click view versions. There's not much here yet. We just created the resource, so there's one version with the date time. And if you click on that, it will tell you it's historic and cannot be modified. And you can see the URI up here uses this kind of special FCR versions endpoint. And then this is just kind of like a numerical representation of the date time at the end here. But that means that you can independently, reference this this version. So we can do another quick modification here. I'm going to give this a title of map of Nova Scotia because that's where I live. You can give it a different title based on where you live if you like. And so I just use my browser back button to go back to the map resource, or you can use the breadcrumb trail here. And then using the update properties box, again, this is the same operation I did before. I'm going to go all the way down to the insert. You can copy this from the slides and paste it if you want. But I'm just going to put in a DC title of map of Nova Scotia and hit update. So, similar to before, the title appears at the top and also in the metadata. And then I think in the next slides here, it's just saying, if we then go back down to this view versions button, you'd see there's two versions now, and then we can sort of compare. This one is a little bit older and it has no title. If I go back and hit the second one, server just took a second there. You can say this one does have the DC title. So, so you have this history of versions. You can revert back to a previous version, not through the interface, but through the command line. You can do that. And kind of just maintain this full history of the various changes that resource goes through over its lifetime.
David, a question here about deleting a resource. If you delete a resource, are the versions also deleted, or are they still available?
Yeah, they would get deleted. So the versions are sort of children of that resource. So if you delete a resource, then all of the children that are beneath it will get deleted. So you do have to be careful too, because if you've built up a hierarchy, for example, if I go back here, I've got this image collection. If I delete the image collection resource, all of its versions go away, but all of its children also get deleted. So, you want to be careful not to, if you have sort of a hierarchy, it's almost like you can kind of think of this, well, as a collection, right? So if you delete the collection, all of its children will also get deleted in all of the versions and all that kind of thing. Now, if you're keeping backups of your repository and things like that, which you should be, then you can sort of revert to a previous state to get that stuff back. But yeah, you do have to be careful. If you're deleting things, that you're paying attention to what resources have children, whether those are versions or child objects in the repository hierarchy. There's just some links throughout here. There's more that you can do with versioning. And that's all documented in terms of just sort of some more complex use cases for that functionality. So I'll talk a little bit here about authorization. I'm not going to demo this. It's a little bit more complex and don't really have the time to demo this particular feature here today, but I'll talk a little bit about how it works. So the World Wide Web Consortium, the W3C, has this standard called Web Access Control. It's basically a way of using properties, RDF properties, linked data for managing authorization. So, in Fedora, for any particular resource or group of resource, you can establish policies to say what users can perform what actions on those resources. So you can have users that have write access, users that have read access, users that have no access. And you can do that based on groups of resources or individual resources, or individual users or groups of users. So that's all documented, and we do have some workshop content that we'll put out in the future that goes into more detail here, but that's functionality that Fedora supports.
Quick question in the Q&A here, David. How does Fedora 6 handle very big files, i.e. when uploading, downloading?
Yeah, so you have a few options there. If you have very large files, Fedora does allow you to host those externally if you want. So, for example, if you already have your sort of file storage figured out and you just want to use Fedora to manage your metadata and your relationships, you can have Fedora sort of reference that external file and point to it, but not actually ingest it into the repository. On the other hand, if you want to put those files in the repository, there are sort of various ways to do that. Uploading a very large file through the HTTP interface is probably not a great idea, just because of the limitations of sort of file-based uploads over the over the internet. But using the command line, you can upload those files a little bit easier, and get them into the repository. It's not really doing anything special in terms of handling those files, but yeah, you can for example use curl on the command line and upload files that way. But if you have use cases around very large files, and you're kind of wondering best practices there, I'd certainly encourage you to jump on we have some links at the end here, but either the technical mailing list or the Slack channel. You could get a little bit more information on sort of best practices there for how to get very large content into the repository in a sort of a safer way.
And there was just one quick follow-up here to the last question about deleting a resource. The question was, so just to confirm, you can't undo a delete through versioning?
So not if you delete the whole resource. If you deleted, say, a version of the resource, then you would still have the complete version history there, and you could restore back from a previous version. But if you delete the resource entirely, then all of the versions associated with it will also be deleted. And then from that point, yeah, you could recover it from a backup, but from the perspective of the repository, that resource in all of its versions is gone. So no, if you delete the entire resource, then versioning is not going to help you retrieve it. But if you delete a version of the resource, then you would still have the rest of the versions there that you could restore from. Is there anything else, Arran? Or good. Okay. Yeah, and feel free to keep the questions coming. And if there's any of them that I'm unable to answer here, again, I would encourage folks, especially if you're really digging into Fedora, to hop on our communication channels. We have a really strong technical team that would be happy to help you out with some of the more kind of complex issues. But yeah, fixity. So I think this is fairly well known, but over time, digital objects can become corrupt. If you've ever tried to use an old CD or DVD and find it just doesn't work anymore, this can just happen over time. And so fixity checks are a way to kind of verify the integrity of files and make sure that they haven't become corrupted over time. So Fedora handles this in a couple different ways. When you put a file into Fedora, when you upload a file, you can provide a checksum with that file. So if you already have a checksum of that file that you're confident in, you can share that with the repository when you upload the file. Fedora will still calculate a checksum, but then it'll compare it against that value, and it will fail the upload if there's a mismatch and tell you, the file, the checksum you provided with this file does not match the checksum that Fedora calculated. Or if you don't already have a checksum for that file, which is fairly common, Fedora will still calculate it, but then it'll just kind of store that checksum as a property of that resource, which will allow you, which is the second thing here, on demand, to recalculate and compare that checksum. So at any time, you can get the server to recalculate the checksum and compare it to the stored value, and it will tell you if there's a mismatch there. So there are some limitations here. There have been some questions around some of this stuff already, so I think this is good to mention. It is really just a check, so you do have to have some kind of plan in place for what you're going to do if the binary file has a bad checksum. Versioning can help you here if you've been changing the file over time. So you could revert to a previous version of the binary file, but if you've never changed that file, then you really only have that one version, in which case having a good backup strategy is a good idea here, to be able to revert back to a known good version if anything ever gets corrupt. I mentioned external files earlier. One drawback is that Fedora can't do fixity checking on external files. It can only do fixity checking on internal files. So if you are storing content outside of Fedora, you'd have to have your own kind of checksum strategy for those files. And there are a few different algorithms implemented, and actually SHA-512 should be on this list as well, but you can sort of determine which digest algorithm is most appropriate for your use cases. Generally, the larger ones take longer to calculate, but are more secure from things like collisions. So I'll do a little brief show of how fixity works here. There's another link to a file if you want to download it, or you can just upload a file that you have locally. But I'm going to create a new binary file inside the image collection container, and I'm just going to call it parade.jpg. So let me go back over here. I'm in the image collection, create a binary, call this one parade.jpg, and I'm going to upload the image. Hit the add button. So we saw this earlier with the Andromeda Galaxy JPEG. You have the checksum, and you have a few other properties here, and then you have the fixity button. So if you click this fixity button, the server recalculates the checksum, and it tells you success, which means that the checksum and the file size match what was originally stored in the repository. Yeah, I'm not going to do this in this particular workshop, but in some other workshops I have kind of gone in and manually corrupted the file just to demonstrate that it will detect if the file is corrupt. You can try that on your own if you like. If you're running a local instance of Fedora, if you want to go in with like a text editor and edit the file you uploaded and run the fixity again, you'll find that it does fail. But here it's a match, so it just gives you the success. But you can do that anytime you want, and you could also script an operation that goes through at various times and checks fixity on your files and reports back if there's any failures. So, fixity is just kind of one part of the sort of preservation tooling that Fedora provides, and just for trying to ensure the long-term stability of the resources in your repository. So simple search is new, and I'll show this one very briefly. This was added mostly for developers and folks that are kind of administering the repository. I'll talk towards the end here about using things like Solr and Elasticsearch for more robust queries, but we do have this simple search endpoint. Supports a set of simple queries. It's built into Fedora. It's based on an internal database index. So in this new version of Fedora, everything's stored on the file system, but then we do have a configurable index. You can use Postgres or MySQL or MariaDB, whatever your preference is. And then based on this index, we can run queries of the resources that are in the repository. So you can see this if I flip back over. There's a little search button at the top here, and if you click that, that'll take you to the search endpoint in the repository. By default, it just returns everything. I think there's a limit on it, but this is just kind of showing everything in the repository. There were questions about what can be searched earlier, and so this kind of gives you a bit of an idea. This is fully documented on the wiki too, if you go to our documentation, if you want to see this in a little bit more detail. But you can choose one of these fields to search on. So you can, if you know the identifier, meaning the URI, you can search based on that. You can search on sort of when it was created or modified. RDF type is fairly common. You could search on that, or size or MIME type. So that's what's supported right now. More other fields could be supported if folks have use cases for those, but these are just fairly common fields that we are guaranteed to be there, and that could be useful for searching. So I'll do a couple of example queries here. Again, you can do a much more complex one, but so we have a resource that uses map in the identifier. So to find that, I could use the Fedora ID. I'm going to use the equals operator here, and I'm just going to use an asterisk as a kind of wildcard to say, give me, anything with an identifier that contains map. So here I've got Fedora ID. I'm going to change the operator to equals, and then I'm going to use the asterisk as a wildcard and just search for anything containing map. And you can see here, it gives me back this map resource that we created, along with all of its RDF types and the content size and when it was created and modified. Similarly, if we wanted to run a search based on MIME type to find the parade JPEG, we could use the MIME type field, the equals operator, and then an asterisk with JPEG as the MIME type. So if we try that, oops, MIME type equals asterisk JPEG and hit the search button. Here I get back this parade resource, which has all of its types, and because it's a binary file, the content size is larger, and it has a MIME type, and then it has created and modified dates. So there's lots more you can do here, and again, this is not at all intended to replace a kind of more user-facing search like Solr or Elasticsearch. This is really more for internal use cases, so you can very quickly and synchronously find content that you've been working on. And I mentioned messaging, and I'm going to say a little bit more about this as well. This is where it gets more to sort of building up a framework outside of the repository. So Fedora does support messaging. If you've heard about sort of asynchronous integrations, meaning kind of fire and forget model, where Fedora sends out a message and then other things can operate on that message without Fedora sort of waiting for a result to return. And these messages get sent out anytime a change happens in the repository. So anytime something is created, updated, or deleted, Fedora emits a message, and that message just contains some brief metadata about the event, what happened, and you can have services set up to listen for those messages and do things with them. And that's where we get into some of the external services and patterns that are fairly common. So we have these message-based interactions. We use Apache Camel for this, and there's a whole Camel toolbox that you can use with Fedora. So you don't have to write code for a lot of these integrations. It's just configuration. But you can have these services that listen for message and do things with them. So different services listen for different messages, and applications like Apache Camel are extremely scalable and fault tolerant. So you can have a really robust ecosystem of services around your repository. And so there's a few common kind of integration patterns here. Indexing for search is very common. So this is sort of when you want to have a user-facing search. And this service does exist. You can stand this up and use it. It's configurable, so you could base this on any sort of property in the repository that indicates whether something should be flagged for search. And you can use things like Solr and Elasticsearch as endpoints here. So every time something changes, Fedora emits a message, and then that gets sent off to this index, and the index gets updated Fedora doesn't depend on the index, so the index could be deleted and recreated. You could re-index everything from Fedora. So that's why it's sort of kind of more robust and fault tolerant, because neither of them are dependent on each other. Well, I suppose the index is dependent on Fedora for the data, but if the index fails and you need to re-index, then you haven't lost anything, because it's all just based on the content that's still stored in Fedora. And the same is true for triple stores. So if you have sort of complex RDF querying use cases and you want to stand up a triple store that would allow you to, for example, use Sparkle to query the RDF, you can do that with basically any triple store you want. We've tested it with a few of these, and there's a tool that allows you to do this now. So all of the RDF from Fedora gets indexed in this triple store, and then you can run complex queries on that. And of course, you can delete and reindex or stand up a different triple store solution. So there's lots of options there. So, and feel free to drop questions in here. I wanted to sort of, that's sort of the majority of the kind of workshop content. I want to talk a little bit about kind of the brief 2021 roadmap. We are doing a presentation, I think it's tomorrow, that'll talk about this in a lot more detail in terms of what's going on with Fedora, but just very briefly. So version 6.0, we've been working on this for about 2 years. And in December, we cut an alpha release, and then in February, a beta. And then just last week, we put out the release candidate for 6.0, and barring any major issues, we would expect by later this month, potentially early next month, to have a full release. If there's no issues, then within the next 2 or 3 weeks, we'll have a release. If we do encounter issues, then we may need to delay it a little bit while we fix those. But there's been a lot of testing that's been going on over the last few months, and we're pretty confident in this release. So I've included some links. If you want to take a look at the release candidate, it's available. You can. That's actually what you're using right now in this workshop is the release candidate. But these sandbox sites will go away probably later today, just because otherwise it's expensive for us to keep them running. But you can deploy Fedora very easily locally. There is a kind of one-click run desktop application if you just want to do some testing. There's a Docker implementation that's very easy to get going with. And then we also have tooling. So if you have, for example, a Fedora 3 site or 4 or 5, and you're interested in migrating, we have migration tools and validation tools that'll allow you to kind of bring your data forward. So that's not relevant if you're sort of not currently using Fedora, but if you are and you're looking to migrate, then we have a lot of tools and documentation to support that.
Question here, David. Does Fedora come with a triple store? Does it have its own triple store, or are the triples stored in a relational database?
Yeah, so that's a good question, and it can be a little bit confusing sometimes because Fedora stores RDF triples, but is not technically itself a triple store. So triple stores generally support kind of complex queries with, Sparkle query. Fedora supports Sparkle Update, and these are slightly different. Sparkle Update is for, creating and updating and managing RDF. So you can do all that in Fedora, but Fedora doesn't have a built-in triple store endpoint. It used to in version 3, and it ended up causing us a lot of problems because the index that, Fedora 3 uses, fell out of support, and then a lot of work went into trying to separate that out so that an external index could be used. So you can use basically any triple store that you want with Fedora. We've tested it with things like Fuseki or BlazeGraph, but there are other tools out there. This is all done through the Camel toolbox and that integration package. If you want some more details on that, feel free to send me a message or put something on the mailing list. I can sort of point you to where all that stuff lives. But it's you basically just sort of stand up this Camel application, and then every time something changes in Fedora, that external triple store will get updated, and then you can query that triple store to get RDF or URIs out of Fedora, and then go back into Fedora to actually retrieve that content. But they're separate. Fedora does have a built-in relational database, but it doesn't have a built-in triple store. That stuff's all external to the software. And of course, I do want to just thank all of the member institutions that support Fedora. I don't think I mentioned this earlier, but Fedora is not just open source software; it's community supported software. So, the only reason we're able to fund positions like mine in Arran and put on, these free workshops and be able to support and sustain the software over time is all of these institutions that support us with annual funding. So I want to say thank you to all these institutions. This is really important for the sustainability of the software. And for folks that are using Fedora but are not yet members, I'd really encourage you to advocate for membership at your institution. It's lots of different funding levels depending on what's sustainable for you, but this is an important way that we make sure the software can live and be supported without depending on things like grants and other temporary funding sources. So we'll leave a few more links here as well. I encourage folks to jump on our communication channels if you haven't already. There's a really great community there, and if you have technical questions in particular, that's really the place to get them answered, whether it's the technical mailing list or the team makes a lot of use of Slack these days. You can generate a free invite to our Slack organization if you want to join there and ask questions and get help. Maybe I can pause there, and Aaron, if there's other questions, I'm happy to answer those.
Yeah, there's somebody just looking for, you had mentioned Docker images. Do you have the link? And they just said they kept hitting the Fedora Linux Docker images.
Oh, yeah. So sometimes there's some confusion, yeah, because the project shares a name with another unrelated project. Let me I'll see if I can grab this for you very quickly, but so the Fedora documentation is a good place to go. And yeah, here we go. So let me just paste this into the chat. So yeah, it's fairly simple. If you're running the desktop version of Docker, you can use this Docker run command. And to get the latest version, or you can request a particular version. And there's a link here to the README if you want to read a little bit more about the Docker setup. And if you're having any issues with it, yeah, again, feel free to reach out or hop on our communication channels for some assistance there. But that generally works fairly well. We've made a lot of really good use out of Docker, and the workshop instances that we're using today are generated using a combination of Docker and an Amazon AWS deployment tool that is also freely available if you have that as a use case. So again, that's basically the end of the kind of formal workshop content. I think we do have a few minutes remaining if there are additional questions. And yeah, we've shared sort of the communication channels, and would encourage people to get in touch if you have further questions, or if you want some help kind of getting started or getting involved in Fedora. If you're on our mailing list, you'll hear about when the new release comes out and other opportunities. We do have other workshops that we're running. We're running a sort of more technical migration workshop in a couple of weeks. And then we're also planning future workshops, both online and eventually in person, but not for a while. So, there's different ways to kind of stay in touch with us and make sure you get the latest content.
There is a question here. Is it a good use case to expose the Fedora API directly on the web, or is it always always a gateway required?
Yeah, so there are some people in the community that in the past really wanted to expose the Fedora directly on the web. Fedora certainly supports that use case. It just so happens that for most institutions, they don't do that. They tend to expose their resources through, for example, Islandora or Samvera as kind of the main interface, and they sort of block access to Fedora on the public web. But there's really no reason not to do that. You probably would just want to have some authorization controls in place, using web access control policies and things like that, just to make sure you're not sort of, for example, exposing write access to your repository onto the open web where people could do dangerous things. But if you wanted to expose read access, for example, and just allow people to pull out the RDF or kind of read your resources and do things with them, I think there's good use cases for that. There's also good use cases for standing up a public triple store endpoint. Sometimes Sparkle queries can be resource intensive, so you do have to be careful there that people don't kind of greatly increase your hosting costs by running very expensive queries all the time. But that is another case that Fedora can support. So you could expose it directly on the web, or expose a public Sparkle query endpoint as a way in. So there's different ways to do that. But in principle, I don't think there's any reason not to, as long as you have reasonable security protocols in place, so that people don't sabotage your repository.
Okay, our time is going. We still have 3 minutes actually. so if you have if anyone from the participants have a question, they can still ask, but we will have to end in 3 minutes because we have another webinar planned and we cannot be late. So is anyone from audience? Okay, I think it's, yeah, I think we should stop here.
Okay.
Okay, so great. Thank you, David. Thank you, Arran. You are wonderful.
Yeah, well, thank you very much. And thanks to everyone for attending. And as I said, feel free to reach out to us anytime. Happy to field additional questions and to help you get set up with Fedora.